Hello, this is Mr. Collier, and today we're solving some application problems in 3D geometry. Okay, so if we look at this 3D figure here, we can find a right triangle and use what we know about right triangles to solve the problem in this instance. So the height of the silo is h, and we have a right triangle with 12 meters and 50 meters here. So we can use the Pythagorean theorem. 50 meters is the hypotenuse because it's opposite the right angle, so 50 squared is going to equal 12 squared plus h squared. So we have 2500 equals 144 plus h squared. And then subtract 144, and we get 2356 equals h squared. H equals square root of 2356. Okay, so we're going to do that in the calculator, get an approximate answer. So the square root 2356 equals 48.5. So we get about 48.5, and don't forget your units is meters. Okay, so next, the room is 6 meters by 4 meters at floor level, and the floor to ceiling height is 3 meters. Find the distance from a floor corner point to the opposite corner point on the ceiling. So first thing we need to do here is draw a picture. I could draw a picture of the floor of a room. Let's try to draw this. It's a rectangle, kind of looks like a parallelogram as I'm going in 3D here. And then I'm going to draw the roof. Okay, so there it is. So 6 by 4 room at floor level. So we call this 6 meters and 4 meters, and then the height of the room is 3 meters. So we want to find the distance from a floor corner point to the opposite corner point. Well, here's a floor corner point. The opposite point would be over here. So this is the longest distance between two points in this room. So here's your distance that we're looking for. Let's call it D. So we're looking for this distance, and the easiest way to do this is to find a right triangle. Now this is full of rectangles, this room, so it should be easy to find a right triangle. So we're looking for this side. What we can do is we can draw in a line to this corner over here, and we know this is going to be a right angle because the floors are perpendicular, or the walls are perpendicular to the floor, so that's going to be a right triangle. So we can use that right triangle. Let me just redraw it over here. I'm going to redraw that in black. So this right triangle has 3 meters here. This is D, the distance that we're looking for. Now, do we know this side length right here? No, we don't. So let's call that maybe X. Okay? We don't know that one, but if you look very closely, this side length down here is part of another right triangle. So let's draw that right triangle. Let's label that X. So let's draw that right triangle as well. This one's flat on the floor. It's 4 meters by 6 meters. Again, this one here is X. So we can find this value of X and this triangle on the floor, and then we can find the value of D, which the question is asking for. Let's find X first. X is the hypotenuse in that triangle. X squared equals 4 squared plus 6 squared. So that's 16 plus 36. So X squared equals 52, and X equals root 52, which is, I'll get that on the calculator, square root 52, that's about 7.2. Actually, if you're going to use this number in your next calculation, you want more digits for more accuracy. Or you can use the exact answer in your calculation for finding D. So that's what I'm going to do. Well, let's keep it green. So I'm going to do that right here. We're going to, well, D is the hypotenuse here, so we're going to have D squared equals X squared plus 3 squared. And we know that X is root 52. So I could square that and then plus 9. Now I could just square the thing on my calculator, or I could square root 52, which is going to give me 52. Let's just see what happens if I do that on my calculator. So my calculator, I have the answer for root 52. If you square the answer now, if I press the square button, it'll square the answer. It'll square 7.21111, blah, blah, blah. So if I square that, I should get 52, and yes, I do get 52. Okay, so if you square the root of 52, you get 52. So that's going to be 52 plus 9. So d squared equals 61. And now I'm going to have to get root 61. So d is going to be about root 61, square root 61 is 7.81. So this is going to be 7.81 meters. Okay, next problem, we have a cube with side lengths 10. We have to find the angle between the diagonal AB of the cube and one of the edges at A. So first of all, let's draw this diagonal AB. It's going to be here. We want to find the angle between this side, this length here, AB, this segment AB, and one of the edges of the cube. So let's do this edge. Okay, let's call that point C up there, and then we can make a triangle. Alright, we've got a triangle here, and we want to find an angle that this diagonal makes with A, so we'll call this one theta. That's the angle we want to find. So let's see what we have here. We have 10. This is 10. This side length here is 10. And we need one more side length in order to figure this out. Now this is a right angle. Okay, that's a right angle. We have a right angle triangle. And we need to find this length. If we find this length, then we can find the angle, because we'll have two side lengths and we can use trigonometry to find the angle. So in order to find that one, I'm going to color this triangle in blue. This is the blue triangle ABC. And in order to find that side length, we have to use another triangle. So there's a common method with these 3D problems. So I'm going to find use this triangle to find this side length CB. So I'm going to call this D over here. Let's draw this triangle first. And that's a right angle, right? So we have this triangle C, B, D. I know the side lengths of the cube are 10, so this is 10 and 10. 10 and 10, and this is a right angle. So we can use trigonometry to find this. I'm going to call this x, and let's solve for x. So x squared equals 10 squared plus 10 squared. X squared equals 100 plus 100. X squared equals 200. X equals root 200. So I'll find, actually I'm going to leave it as exactly root 200. Okay, I don't need my calculator yet because that's not the final answer. Let's see if that works. Okay, now we'll try to find the angle theta. So let's draw the blue triangle here, ABC, triangle ABC. This is C, B, and A. This is theta. We know this is 10, and now we know this is root 200. Okay, so here we can use trigonometry. I'm going to write out SOHCAHTOA. And which one do we use? Well, we have the opposite here. This is opposite to theta, and this is the adjacent. So I'm going to use tangent. So tangent of theta equals root 200 out of 10. So theta equals inverse tan of root 200 out of 10. Okay, so that theta is going to be inverse tan of root 200 out of 10, which I'm going to do on the calculator. Second function, inverse tan root 200 divided by 10. Okay, make sure that divide by 10 is not under the square root sign, or it'll square root the 10 as well. So you get 54.7. So it's about 54.7 degrees. Okay, next. A symmetric square-based pyramid has base lengths of 6 and a height of 8 centimeters as shown. Find the measure of angle TNM. So the N is the angle in the middle. Okay, so that's TNM here, so we're looking for this angle right here, which I guess I'll call theta. Alright, now let's redraw that triangle. Okay, so here's theta. This is 8 centimeters, so we need one more side length in order to find the measure of angle theta. So it gives us also that the base lengths are 6, so that means that this is 3 and this is 3, and we're going to have to, oh yes, we can check it out on this side. There's also 3 and 3, so that means in the middle here, this is 3 and this is also 3. So we do have the other side length. This is going to be 3. And now we can find theta using trigonometry. So I'm going to write a SOHCAHTOA. And we have opposite and adjacent here. Opposite and adjacent to the angle theta. So we use tangent. So tangent theta equals 8 out of 3. So theta equals inverse tan of 8/3. Okay, so we can do that on the calculator. Inverse tan of 8 divided by 3 is 69.4. Okay, that's the answer to part A. Part B, angle TRM. So angle TRM is here, so this TRM is this angle. Okay, so it's that angle right there. Let's call it X this time. So I want that angle there. I can see a triangle at that sense. Let's draw that triangle. So this is T, and this is R, and this is M. This is a right angle. We know the height of the pyramid is 8. We're looking for this, let's call it X. Looking for this angle. We need one more side length in order to figure this out. I guess we could figure out this one right here. I'll call it Y, this side length. Alright, we can figure out that one there because if you look real closely, there's a triangle involving the side length MR right here, a little right triangle, and we know the side lengths of that little right triangle. So let's look at that one. So that one's a right triangle, and it's 3 and 3, and then this side length is Y. Okay, so we can figure out Y, and then we can figure out X, the angle here. So this is a right triangle. We do y squared equals 3 squared plus 3 squared, y squared equals 9 plus 9, y squared equals 18. Now y equals root 18. I'm going to leave it exactly as root 18. Then I'm going to go back to this green triangle here and solve for the angle x, right? Okay, so in this triangle we have opposite and adjacent. So again, we're going to use tangent. So we have tangent of the angle, which is x, equals 8 out of y. So x equals inverse tan of 8 out of y. And we know y is root 18. So we can just put that in and then get the answer on our calculator. Okay, so we're going to do inverse tan 8 divided by square root 18. And we get 62.1 degrees.